So the second part of our lesson today is determining the relationship between our variables. So we're going to look at if it's positive, negative, or zero before we calculate. And then again, we'll practice determining that rate of change. So first we need to figure out what our variables are. Well, before we figure out if they're both increasing or decreasing, we need to figure out what they are. So I think I have steps 1 and 2 backwards. So you may want to flip those around. So tickets for Valley Fair. When I was in high school, because I looked at the price and I could not believe it, I think it's about $37 to get into Valley Fair now, are $30 for two what? And $45 for 3. I don't have any labels on my 2 and 3. But when I read the question, I'm talking about 2 tickets for $30 and 3 tickets for $45. All right, so determine if the variables are both increasing. From 30 to 45 is an increase, and from 2 to 3 is an increase. They are both increasing, so the relationship is positive. The more tickets you buy, the more you pay. Okay? And then determine the independent and dependent variables. So we don't have time, so now we have to ask, does the number of tickets we buy depend on how much we pay? Or does how much we pay depend on how many tickets we buy? Hopefully, again, that second sentence was what made sense to you. How much we pay depends on how many tickets we buy. So here we've got our x and y. So we're going to find change in y over change in x. Change in cost was from $30 to $45. And change in tickets went from 2 to 3. So it was $15 per ticket. Sorry, the last step is setting up that ratio we just looked at. All right, second example, the late fee for a video rental is $2. So there's our first variable on the first day, and $2 day on the first day and the 7th day. So that's our second variable. We have time, so there's our independent variable. So our dependent variable is the cost. All right, so as the number of days increases, what happens to the cost? Nothing. This is our zero slope. If we do change in y, remember x is independent, y is dependent, the change in cost is 0 from the 1st to the 7th day, so it costs an additional $0 per day that it is late. The late fee is constant. Last example. So we've got a house. If a house is not built on time, the price paid to the builder is reduced by $50 after 2 days and $75 after 3 days. Reduced. So we need to keep that in mind. As the number of days, sorry, I forgot to identify my variables. So we had $50 and 2 days. So we know that days is our independent variable. And the dependent variable is going to be cost. So as the number of days increases, the price that is paid to the builder decreases because that's what reduced means. Okay, so this is a negative relationship because as the number of days goes up, the amount the contractor is paid goes down. All right, change in y over change in x. Last piece is to calculate this rate of change. So the change in cost goes from 50 to 75. Remember, that's a reduction of $25 that the builder is being paid. And from 2 days to 3 days is a 1-day change. So each day that the house is not built on time, the builder loses $25 of pay. And your U-try problems.